This video is about products and expansions. So a product of two factors is the result obtained when you multiply them. So the word product means to multiply, and the factors are the things that are being multiplied together. So in these examples, we just have some simple products to find. -3 multiplied by 4x is -12x. You multiply the -3 by the coefficient. A 2x multiplied by a -x to the second power. We want to multiply the two coefficients together, and that would be this 2 and this -1 that's in front, and that gives us -2. And then we want to do the x times the x squared, and that's like adding the exponents together. So an x to the first power times an x to the second power gives us an x to the third power. And that's because x to the first looks like x squared looks like x times x. So in the end, it ends up being x times x times x, which is x to the third. And then here we want to multiply our two coefficients, -4 times -2, which is +8, and x times x to the second to give us x to the third. So we're practicing some mechanics of multiplying with variables and exponents. Expansion is another way of saying distribution. So if you have to expand something, it means to get rid of the parentheses by doing any distributing that you have to do. Distributing is multiplication of a single coefficient by both terms, or 3 terms, or 4 terms that are inside of parentheses. So this 3 is getting distributed through. So we're expanding this and finding the product, which is going to be 12x plus 3, because the 3 has to get multiplied by the 4x and by the 1. In this example, we have a 2 times 5, which gives us 10, and there's an x beside it. And then a 2x times a -2x, which will give us -4x squared. And then in the third example, -2x times x is -2x squared. And -2x times -3, remember a negative times a negative is a positive, so plus 6x. You might be asked to expand in multiple places and then look for like terms to combine. So combining like terms is the simplifying step that you have to do at the end. Here we have to distribute the 2, so expand the first parentheses, and distribute the 3 to expand the second parentheses. So we end up with 6x minus 2 plus 15 minus 3x, and now I'm looking for like terms across this expression to combine. The 6x and the minus 3x gives us positive 3x, and then the minus 2 and the plus 15 gives us positive 13. And you stop when there's nothing left to simplify. Similarly down here, but with exponents, we have x times 2x, which gives us 2x squared, and x times -1, which gives us -x. That's what I got from expanding the first parentheses. In the second parentheses, notice you're expanding by distributing a -2x, so it ends up being -10x, and then plus 2x squared. Now we're looking for things to combine. I see a 2x squared at the front and a 2x squared at the end. When you add like terms with a squared together, you just keep the x squared as x squared and add the coefficients together. And then a -x and a -10x gives us -11x, and stop when there's nothing else to combine. If you have to expand a binomial with another binomial, you can use a trick called FOIL, which stands for multiply the first 2 terms, multiply the outer 2 terms, the last 2 terms, the inner 2 terms, and the last 2 terms. Or you can just think about it as distributing both things from the first parentheses to both things in the second parentheses. So I need to start by distributing the 2x to the 3x, which gives us 6x squared, and then the 2x to the -7, which gives us -14x. That's the F and the O of FOIL, first and outer. And then you need to distribute the 1. 1 gets multiplied by 3x to give us positive 3x, and that's the I of FOIL for the inner 2 terms. And then the L of FOIL, distribute the 1 to the -7. And then you look for like terms to combine, and if you've gone in the FOIL order, it's usually the middle 2 terms that are going to be like terms, and then stop when there's nothing else to combine. A special case of binomial expansion is when you're multiplying 2 binomials together that almost look identical, but one has a plus and one has a minus. What's going to happen is the 2x times 2x gives us 4x squared. The 2x times -1 gives us -2x. When we go distribute the 1, we see a plus 2x, and then the final term is going to be -1. The middle 2 terms, the like terms, are the opposite of each other, so they add up to 0 and they go away. So you end up with fewer terms than you might think, because the middle 2 terms cancel each other out. Sometimes this is written as a formula, known as the difference of squares formula, that if you see 2 factors being multiplied together, where one is the same as the other but with a minus instead of a plus inside, you can automatically write the product as the first squared minus the second squared. So that's why it would be called the difference of squares, which you can see works in the example that we just did. I tend not to use the formula. I always just distribute it all out, and you end up with the same answer. Another special case of binomial expansion is when you have a binomial written with a squared outside. This means 2x plus 1 times another 2x plus 1, right? Because that's what a second power means. It means take the thing, multiply it by itself. It does not mean, and I'm going to change colors to show this, it does not mean that you're taking the 2x plus 1 and you're distributing the squared. That does not work. So you're not allowed to just say, oh, well, 2x times 2x, that gives me 4x squared, and 1 times 1 gives me 1. So this is not okay. It's a very common mistake to do that. We don't want to do that. What it means is to write it out twice and actually distribute. So we have to do first, outer, inner, last. First, outer, inner, last. And you can see that the middle two terms here do not cancel each other out. In fact, they add together to give the middle term of 4x, which is the correct answer, as opposed to this, which didn't even have a middle term because it violated a rule. Algebra. Sometimes this is also written as a formula. This is called the perfect square formula. A perfect square because the original expression is written as a factor squared. Again, I tend not to use these two formulas. I just distribute it out, and you'll get the correct answer anyway. If you have to do further expansions, like multiplying a binomial multiplied by a longer thing called a trinomial, or 3 binomials together, just be systematic about your distributing. You can't call it FOIL anymore because it's not just first, outer, inner, last. You have to take the 2x from the first parentheses and distribute it to each term of the second parentheses. So it would be 6x to the third power plus 2x to the second power minus 4x. And then take the 1 from the first parentheses and also distribute that to everything in the second parentheses. So I switched colors so you could see where I'm obtaining these numbers from. But in the end, you end up with 6 terms. That's because there was 2 in the first parentheses and 3 in the second. There should be 6 terms, and then you look for like terms to combine. And here we have 6x to the third, no like terms. We have a 5x squared from combining the 2x squared terms, a minus 3x from combining the 2x terms, and then a minus 2 at the end. If you have to do 3 binomials together, you want to start by multiplying 2 of them together using FOIL and ignore the other one. For now, simplify that. And now this thing in green gets multiplied by the original x plus 4 that we had ignored at the beginning by doing the procedure as shown up at the top of this slide. So systematic distribution. And that is all.